But as I said earlier, photons for me, I mean, there are other entryways, I guess, to quantum mechanics, but to me, photons are the true gateways to quantum mechanics
Okay.
in multiple ways as well. The first way is that photons are packets of energy, packets of bite size. I wouldn't say indivisible because you can have like different energy photons, but
No,
they come
it's
in.
totally divisible, right? It's HF, right?
Yeah, but I mean like one photon itself is its own like singular quantized packet of energy, right? So what does that even mean, right? Because did we ever really define like what a quantized packet of energy
No, I
is?
don't. I mean, I
Yeah.
think we went over it in an episode where we were talking about like quanta and like the whole definition of where quantum came from, maybe.
Oh yeah. I
But
guess
I
we
don't
could.
think we went into it. You can go ahead.
Well, anyways, it basically just means that, you know, if you are emitting a photon, then you like let's say you're emitting a photon at frequency or at wavelength lambda, then wait, what's the equation again? We haven't done this in
Yeah,
in like a
it's the
year.
summer, guys. It's the summer.
Energy equals
E equals HF is your fundamental
right,
equation.
right. E equals hf.
Yeah.
So you divide h by the wavelength, and you
Hmm.
get that set amount of energy. So for example,
Or
when
H times velocity over the wavelength, because
sure,
frequency equals velocity over wavelength.
yeah. So when you look at the what's it called, the photoelectric effect,
Yeah.
boom, that's when you get to see like the particle side slash like quantized wave packet side of photons, where you can actually see the effects of like singular photons being absorbed by electrons and all that stuff.
Hmm.
um, but when you start looking at different experiments, different setups, you start talking about waves. And as I just did, which is kind of very counterintuitive, which is, the entire topic of quantum mechanics is counterintuitive. But notice how I was talking about quantized photons that are, particle like, but I use the word wavelength when describing the energy of this photon. So where does the wave actually come into play, right? Well, this was one of the greatest debates of all time, excluding the Niels versus Einstein debate. And it's what is light? Is light a wave? Is light a particle? When you get into high school physics, they kind of just tell you it's both, and just accept that it's both. And then when you get to university, they say the same thing, because truly we don't know why. We don't know why light has properties of waves and properties of particles depending on when and where and how you look at them. But it's one of those properties of the universe where maybe eventually we'll have an explanation, and maybe not.
It's just that, but I think there's kind of, I mean, my interpretation of that at least was that light is in fact fundamentally a wave, but like traversing the universe, like it is fundamentally a wave. And wait, how was I trying to think of this? Because it's kind of interesting when you have to describe, because when you say they're packets of this energy, you're kind of describing it in terms, as you said, of particles, right? And when you say, okay, I'm directing it towards, like, for example, if let's say some explosion happened somewhere, and when I'm saying explosion, I'm saying like stellar, astronomical, supernova, or some kind of explosion, the light, the light would totally just reminate outwards in all like circular direction, right? Right. So
Yeah,
I was
but
just thinking, would
there's more than one
I guess that's not
photon,
really,
right?
no, not really. I'm just trying to, I guess I'm trying to think of this as I'm talking about it, so I don't really have my thoughts, truly thought about, because I was thinking about this interesting idea right now, but I don't think. Maybe it's not fundamentally a wave. Maybe it's just fundamentally both. Because I know
Yeah.
the whole thing of
I
the wave particle duality agreement is that it's mathematically a wave, right? That's the big thing. That mathematically we can represent this and we can see properties of it being a wave. But when we look at it, it behaves like a particle.